So let's talk about relations and functions. A relation definition is a set of ordered pairs. Okay, it's a set of ordered pairs that have where the ordered pairs have a relationship from one to the other. And relations can be written a lot of different ways. They can be written as I said, a set of ordered pairs. It can be written as what we call a mapping here. Okay, and you notice I use a couple words here, domain and range. Okay, now every relation has a domain and range. And the domain, the definition is the set of x values. So as I look at, like for instance up here, this example of a relation, the domain would be all the x values, so 3, 7, and -3. The range is the set of y values. Now there's a couple little rules that we want to follow when we describe our domain and range. For instance, if we come down here to this example, okay, it says state the domain and range. So domain is all the x values, so it would be this one, this one, this one, this one. And what we want to do is we're going to use our set notation, okay, and then we're also going to label them from least to greatest. So -1, 2, 3, and 6. The range, again, is the set. Okay, and you notice here we have all these. Now, again, we're going to label them in order. So 3 is the smallest, then 4. And then the other rule we're going to follow is we are not going to repeat values. So there's only, since there's 2 5s here, we're just going to write it once. Okay, so you're going to use set notation. You're going to put it in order, and then don't repeat values. Okay, so let's try one more. Okay, so as I look at this one, I see my domain. Let's see here. -4 is my smallest. -2. Looks like I have repeating 1, so I'll just write it once, and then 2. And then my range. Let's see here. Looks like -3 is my smallest. And then it looks like possibly 5, and then 6, and then 8, and then 9. Okay, so they don't have to match up. It's not like the first element in the domain has to match up with the first element in the range. Even though I know these two do this time, but it doesn't have to work out like that. So a lot of times it does, but it doesn't have to. Okay, so let's move on. Let's talk about this thing called a function. A function is a special type of relation. Okay, it's a relation where the ordered pairs have no repeating x values. Or as it says right here, it's a set of ordered pairs where no two ordered pairs have the same first element. So in other words, x values can't repeat. So if we look back at the first example I gave us here, here's a relation. Now is that a function? Yeah, it is, because if you notice, none of the x values repeat. They're all different. The y values, we have some that repeat, but we don't care about that. That's not part of the definition. Let's look at the other example here. What about here? Is this a function? No, it's not, because you notice here that these x values are the same. So this would not be a function, but the other example would be. Now, that's one way to tell if something's a function. You can also tell something is a function if I'm looking at its graph. Okay, for instance, if I have this graph right here. And what we're going to do is we're going to follow what we call the vertical line test. And the vertical line test says exactly this. It says that if I take a vertical line, so let's say I take my pen and I hold it in a vertical direction, and if I lay it across the graph, if it only crosses once, then it's a function. So this line that I have here is a function because no matter where I put my vertical line, it only crosses once. Versus a graph like this, if I were to take my vertical line, you'll notice that it crosses twice. Okay, and that means it's not a function. Okay, so vertical line test will help us determine if something is a function by looking at its graph. Now, the next thing that I would like to talk about is something that's called function notation. Now, function notation, a lot of times people don't like it very much, but it's another way to write equations. And I've written an example here of function notation. And function notation, here's probably the biggest difference here, is this part right here. Okay, and the way you say this is f of x. F of x equals, and I just made this up, ax plus b. It doesn't have to be ax plus b. Okay, but for something for you to understand is that this first letter, f, that's just the name of the function. Okay, it's function f. I can have it as h, I can have it as l, t, whatever you want. Okay, but that's the name. And then the variable here, this doesn't mean f times x. This is just simply telling me what variable I'm using over on this side of the equal sign. Okay, and that's it. So, for instance, if I have this function, f of x equals 2x plus 3. If I wanted to know what f of negative 1 is, okay, I'm just going to simply replace the x with negative 1 and solve. So if I did that, I'd get 2 times negative 1 plus 3, which would simplify to be 1. And so I'd get f of negative 1 equals 1. Well, what does that mean? Well, what that means is, if we're thinking about this in terms of like a point on a graph, that when I plugged in negative 1, I got 1 as an answer. Okay, and this is why sometimes when we talk about coordinates or ordered pairs, people will call the x-coordinate an input value, because I plugged that in first, and the y value as an output. Okay, so let's do another example here. Let's say I have another function, f of x equals 0.5x minus 3. And I'm going to tell you that my domain is negative 2, 0, 2, and 4. So in other words, that I have 4 points that are on, if I were to graph this line right here, okay, there's 4 points, and these are the x-coordinates. I want to know what are the y-coordinates. Well, what I'm going to do is just simply plug these into here. So I'll start out by just writing f of negative 2 equals 0.5 times negative 2 minus 3. Okay, again, this doesn't mean times or anything like that. I'm just going to rewrite it. F of negative 2. 0.5 times negative 2 is negative 1. F of negative 2 equals negative 4. So when I plugged in negative 2, when I plugged in negative 2 into this function, I got negative 4 as an answer. Okay, so let's do it again. Let's do 0 this time. Okay, so it would be f of 0 equals 0.5 times 0 minus 3. So f of 0 equals, well, that cancels. I get negative 3. So when I plugged in 0 into function f, I got negative 3 as an answer. All right, let's try the 2. So I'd plug in f of 2 equals 0.5 times 2 minus 3. F of 2 equals 0.5 times 2 is 1. So f of 2 equals negative 2. Last but not least, f of 4. So 0.5 times 4 minus 3. So f of 4 equals 0.5 times 4 is 2. F of 4 equals negative 1. So when I plugged in 4 into function f, I got negative 1 as an answer. So what's my answer? What's my original answer here when I'm asking about the range? Well, it would be negative 4, negative 3, negative 2, and negative 1. Okay, and that's really all you need to do in terms of if you're being asked to find the range, is you just have to go through and plug in all these values. And it's a little bit of work, no doubt, but that's how you do it. Well, let's move on. We got a little bit more we want to talk about. Okay, what about this? Okay, so let's say I tell you that here's a function, okay, and instead of an equation, I give you the ordered pairs. And I want to know what's the indicated value. So in other words, if I knew what the equation was, and I plugged in 6 into the equation, what answer would I get? Well, the answer I would get would be 12. Well, how do I know that? Well, because when I look up here, I look at these ordered pairs, I see right here I have 6, 12. So this means when I plugged in 6 into whatever this function h is, okay, we don't know what it is, it's h of x equals something. But this is telling me when I plugged in 6 into that function, I got 12 as an answer. What about if I were to plug negative 2 in? what would I get? Well, I would get 4. Why? Because right there it says when I plugged in negative 2, I got 4 as an answer. What about here? H of 8. Well, I'd get 14 because right here it says that I plugged in 8, I got 14. Last but not least, H of 4, 10. So when I plugged in 4 into whatever this function was, I would get 10 as an answer. Okay, makes sense? Hopefully it does. So let's finish up. Let's talk about this last part here that I have. Okay, what if I give you a couple functions like this one? I give you f of x equals this and g of x equals this. What does this mean? Find f of negative 2. Well, what that means is you just simply plug in negative 2 into that function, into f, and just solve. So f of negative 2 equals 2. Negative 3 times negative 2 is positive 6. So f of negative 2 equals 8. There you go. That's it. Versus this one, what if I want to know g of 5? Okay, well again, remember the first letter means it's just the name. So it says use this function right here. So I'll do g of 5 equals 2 times 5 minus 1. So g of 5 equals 10 minus 1. So g of 5 equals 9. So when I plugged in 5 into g, I got 9 as an answer. But what if I come across a problem like this, where it says f of 4 plus g of negative 1? Well, what that means is you simply are going to plug in 4 into f, get the answer, plug negative 1 into g, get that answer, and then add those answers together. So it's like two problems in one here. So if I do f of 4, so it'd be 2 minus 3 times 4, which f of 4 would equal 2 minus 12. So f of 4 is equal to negative 10. And then over here, if I did g of negative 1, that would be 2 times negative 1 minus 1. So g of negative 1 would be negative 2 minus 1. So g of negative 1 would be negative 3. So this is saying add those together. So if I just do negative 10 plus negative 3, I get negative 13. And there you go. If I f of 4 plus g of negative 1 is equal to negative 13. Now if you understood that, then hopefully you'd understand this one. This one says f of 0 times g of negative 3. So we're going to just follow kind of like what we did in the last one. We're going to find f of 0 and find g of negative 3 and then multiply them together. So let's do that. So f of 0 equals 2 minus 3 times 0. So f of 0 equals, well that goes away, so f of 0 is 2. Well, let's do g of negative 3. So g of negative 3 is equal to 2 times negative 3 minus 1. So g of negative 3 is equal to, looks like negative 6 minus 1. So g of negative 3 is equal to negative 7. So last thing, it says multiply those answers together. So 2 times negative 7 is negative 14. And there you go. That's the basics of relations and functions.